Okay, so actually let's ask that question. So Bianca asked, do you also need to add the plus c for this? No, because it's an integral, not antiderivative. No, because it's a definite integral. No, because there's a limit in the integral. Eh, that's not quite the answer. So let's discuss this. So when I write this, right, what does this symbol mean? This symbol means the most general possible antiderivative of the function x squared with respect to x. So in other words, give me the entire class of functions. Give me every possible function of x whose derivative is just x squared. So that we know is 1/3 x cubed plus c. So that's where the plus c comes into that matter. Because I have to write down every possible function that has a derivative of x squared, and I can always add a constant and it doesn't change that derivative. Now, what if I ask you to find what is the integral from, say, 0, let's make it a bit different. Let's say 1 to 3 of x squared. Okay, well, now I know that the final answer is going to be a number, right? Because this represents what is the area underneath the graph of y equals x squared from x equals 1 to x equals 3. So that's a number. However, I do use antiderivatives to calculate that, right? So I calculate any antiderivative. I don't need a plus c because any antiderivative will actually do the job. All of them will give me the same answer. Then I plug in the numbers, right? And I get 26 over 3. Okay, now what if I asked you to calculate the integral from 1 to x of t squared? Now this is a bit different. So this is a number, right? It represents the area underneath the graph of y equals t squared from t equals 1 to t equals x. It is just a number, but it's a number that's going to depend on x, right? Because I don't know what that upper limit is. So according to fundamental theorem of calculus, I take an antiderivative, that's 1/3 t cubed, and I plug in t equals 1 and t equals x. So I get 1/3 x cubed minus 1/3. Now, what if I were to then differentiate that function? Again, notice no plus c, right? Because I'm not finding an antiderivative here, right? This is not an antiderivative. This is area under a curve. It just happens to be a function of x. Now, what if I were to take the derivative of that? According to fundamental theorem of calculus, the bottom is a number, the top is just x. So I just replace the t with an x, right? I mean, obviously, in this particular case, you could have also just taken the previous work and done that also. So the reason why we really don't need a plus c here is because, first of all, we're taking a derivative. Derivatives never have a plus c, right? The reason why that plus c occurred in the first place is because antiderivatives have a plus c, right? If you want to find all possible functions whose derivative is, say, x squared or sine x or whatever, you need a plus c because that tells you, we've learned that you only need one antiderivative and then all the other antiderivatives can be gotten by a plus c. But this problem is actually asking for a derivative, so it makes no sense to say the derivative has a plus c. And all of you actually said we don't need it because it's a definite integral. Again, it's not a definite integral, it's actually a derivative. So I just wanted to kind of do these 4 examples very quickly to kind of show you the difference, or kind of the layers here. Does that kind of clear everything up for everyone? That was actually a good question, Bianca, about the plus C.